recording now, sir. We are. Okay, listen up. Shh, guys, come on. So today we're talking about graphing inequalities. You guys have only graphed inequalities on a number line. Today we're going to graph what's called linear inequalities with two variables. So it's going to be in the form like y equals mx plus b, but it's not going to be equals. It's going to be y is greater than or less than mx plus b. So I want to talk about VUX. Nope, I said VUX. So listen, listen. V stands for, we have two types of special lines. Do you remember? V is a vertical line. The U tells me that the slope is undefined. Good job, Dakota. And the X tells me that the equation is X equals, and then we're going to put some number here, right? That's how you write the equation to a vertical line. Do you guys remember that? Like X equals 5 is a vertical line crossing the X axis at 5. We don't use Y because we don't care what Y is when it's a vertical line. X is always going to be 5. Okay. We got that? Okay. The next one we have is HOI. So what kind of line are we talking about? What's the H represent? Horizontal. And that O is actually what do we know about the slope? Do horizontal lines ever rise? They do? They rise? They never rise. So that means their slope is what? 0. So that O is not really an O, it's a 0. That's referring to my slope. Slope is 0. And I'm going to write slope up here as well. And the equation to a horizontal line is y equals some number. Okay. How do we feel about that? Indifferent. Okay. Well, that's better than awful. Okay. Just tell me how you really feel. Okay, here we go. So let's talk about graphing equations on a number line or graphing inequalities. So we just did an activity. So we know if it's the less than symbol, it's going to be an open circle. I'm going to put the 3 here and I'm going to shade in this direction. You guys already know that because we just did a warm up about that. This is the symbol less than. I don't know if you want to write that down or not. Open circle. I'm going to put the number 6 here and I'm shading to the right. And this is the symbol is greater. I always spell that word wrong. Greater than. I don't know why, but I think it should be like OR, like greater instead of greater. I don't know. Thanks for that. Thank you. Okay. Next. So if I have the less than is less than or equal to symbol, I'm going to have a filled in circle. I'm going to put a -4 here, and I'm still going to shade to the left.
Which one's the one where you shade all of it? What's that one like that?
That's a compound inequality. We're not doing that. Okay, but that's a great question. And then here, greater than or equal to, I'm going to put the number -3 here and fill in my circle and shade to the right. So with linear inequalities, we kind of do the same thing. Okay, kind of do the same thing. So I want to, what do we know about x equals some number? What kind of an equation is that? We just talked about it in the VUX. Well, it's undefined. The slope is undefined. What kind of a line does that make? A vertical line. So I'm going to go to -2 on my x-axis, and I'm going to draw a vertical line. Okay. So that's the first thing that I'm going to do. Yes. Shh, I do. Okay. Sorry. Here's the next thing I'm going to do. So first, I'm going to draw the line. And because it's greater than or equal to, I know that I'm going to use a solid line, much like a filled in circle, right? Because this would give me a filled in circle. So my graph is going to be made with a solid line. But the other thing that we have to do is we have to choose a test point. So we have to select a point that is not on the line and see if it works. So I'm going to tell you what I mean by that. So I think that I want to change my color to red. So I'm going to choose, I try to always choose the test point 0, 0 if it's not on the line. So I'm going to choose that test point 0, 0. Okay. So the point that I'm choosing is the ordered pair 0, 0. And I'm going to take that and I'm going to plug it into my equation for my inequality. So my inequality is x is greater than or equal to -2. So if my point that I'm talking about 0, 0, the value of x in that case is 0. So is 0 greater than or equal to -2? Is that true? Yes or no? Is 0 greater than -2? Yeah, it is. So I'm going to shade anywhere on the side of the line where the test point lies, because the test point makes it true. Because remember, this is an inequality, and when we graph inequalities on a number line, we have to shade in the direction that it points. Ma'am? Uh-huh. So let's try something else. What kind of a line is y equals? It's a horizontal line. So this says y is less than. If I were to put this on a number line, is this going to be an open circle or a closed circle? Open circle. So open circle is the same thing as a dashed line. So I'm going to go to where y is 1. That's this right here. And I'm just going to put a dashed line. It is not a solid line. And it's not a solid line because it doesn't include the number 1. It's everything that's less than. All the values of y that are less than the number 1. So I can't include the number 1. That's why I use a dashed line. Okay. So which way do you think we're going to shade? If we're talking about all of the values of y that are less than 1, are we going to shade above our line or below our line? We're going to shade below our line. Just like we would shade the inequality on a number line, we have to shade it when it's linear. Okay. That means, so let me talk to you about what that shaded area represents. That means any number in this shaded region, any point in this shaded region is going to be a solution. So this has a y value of -2. Is -2 less than 1? Yes. This has a y value of 0. Is 0 less than 1? Yes. Is this has a y value of 4? Is 4 less than 1? That's why it's not in the solution set. It's not in the shaded region. Okay. Have you guys ever seen linear inequalities like this with two variables? This is all new. Yeah, all new? Okay. You what?
That's why I felt
Shh, okay.
Maybe it's water up there. Well, except for the bread.
Okay, are we able to keep going, guys and gals? Okay. So let's talk about what we noticed. When you have a greater than sign or a greater than or equal to sign, it looks like you shade to the right or above the line. And when you have a less than or a less than or equal to sign, it looks like you shade left or below the line. Yeah. Oh my goodness. Sir. No. You can't leave during instruction. You'll be fine. Swallow your spit. You'll be fine. Shh. Okay. So we are going to turn around. You'll be fine. You'll be okay. Yes. So greater than means to the right or above the line. Less than or less than equal to is left or below the line. Okay, here we go. So we're going to graph the linear inequality, and here's the method that you should always follow. The first thing that you should always do is make sure that you solve for y. Put it in y equals mx plus b. Why? Why are we doing that? What's the purpose of that? Kane. So you know where to begin, and then you can count your slope. Yes. Do you see this special note here? Because we're dealing with inequalities. It says, if you multiply or divide by a negative, you must do what? Yeah, flip the symbol. Do you guys remember doing that? Okay. If you multiply or divide by a negative, you have to flip the inequality symbol. You should always identify your slope and your y-intercept. Remember, your y-intercept is where you begin, and then you go from that point and you count your slope up and to the right or down and to the right. And then we're going to shade the region that makes the inequality true. All right. So are we ready to start this one? Okay, so step number 1, we're going to solve for y. So I have 2x minus 3y is less than 6. What should I do first? I'm trying to get y all by itself. Subtract 2x from both sides. Very good. That leaves you with negative 3y is less than negative 2x plus 6. Gavin? I'm dividing by what? What happens when I divide by a negative? What's this note up here say that I put the little asterisk by? Yeah, I'm dividing by a negative, so that's the special thing. Flip the inequality. So instead of it being less than, now it's y is greater than. That negative 2 over negative 3 becomes a positive 2 over 3x. And a positive 6 divided by a negative 3 becomes a negative 2. So where do I begin? I begin at negative 2. What is my slope? 2 over 3. Is my line going to be a solid line or a dashed line? Here's my symbol. Does that make that line solid or dashed? Dashed line. Good job. Okay. So I'm going to begin at negative 2. And from there, I'm going to go up 2 and to the right 3. And then I'm going to do that again. Up 2 and to the right 3. And I'm also going to go down 2 and to the left 3 because I want to make sure I have a nice dashed line kind of going through the points. So there is my dashed line. Okay. So let's use the test point. What test point do you guys want to use? What's a point that we can use that's not on the line that's going to be the easiest point to plug in? 0, 0. So if I use the ordered pair 0, 0, it's going to tell us which way to shade. So remember, I'm just taking the y and the x and replacing them with a 0. So y is now 0 is greater than 2/3 times 0 minus 2. Well, what is 2/3 times 0? 0. So I really have 0 is greater than -2. Is that true? Yes, it is. So I'm going to shade where the test point lies. So I'm going to shade in the region that the test point lies. Okay. Let's do it again. So is my equation in y equals mx plus b form? No, it's not. So I have 3x plus y is less than or equal to 3. What do I need to do to solve for y? What do I need to do to get y all by itself? Go ahead, Gavin Kane. Yeah, subtract 3x from both sides. So that gives me y is less than or equal to -3x plus 3. Solve for y. So what is my m? What is my b? Dakota, what's my b and my m? Awesome. Awesome. Good job on that. Am I going to have a solid line or a dashed line? Aiden, solid line or a dashed line? Solid. Good job. So I'm going to begin at +3. And from there, I'm going to go down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. And then I'm going to connect my points with a nice solid line. I'm going to change color for my test point again. I'm going to use the test point 0, 0. And I'm going to plug that into my original equation, okay? So I'm going to replace the y with a 0. Is 0 less than or equal to -3 times 0 plus 3? Is that true? Is 0 less than or equal to 3? Because that's what you end up with, right? Yeah, that's true. So we're going to shade on this side. It's me. I'm sorry. It's because here's the thing. Yeah, I had to get a check. I had to put down money, and my husband is the person that's doing that all. Because, well, he's not working today. He's off. No.
Oh, today I work from 4 to 8:30.
Okay. All right, number 3. What are we going to do to get y all by itself? Number 3. What are we going to do to get y all by itself? Okay, we're solving. We're just graphing. Instead of graphing y equals mx plus b, we're graphing an inequality. Remember, inequalities have a shaded region. That means that like x is greater than 5. That means that it could be a multiple numbers, right? Think of all the numbers that are greater than 5. So we're just saying any point, any ordered pair in this region would be part of the solution. Any point would make that inequality true.
So basically just solving for y and then putting it in y for the next
Yes, and then graphing it. And then shading the area that makes it true. That's exactly what we're doing. Okay. All right. So here's this equation or inequality. 2x is greater than negative 3y. So I want to what do we want? We need to get the y on the left and the x on the right. Okay. So we'll subtract 2x from both sides first. So that's going to put a 0 over here right now. So 0 is greater than negative 3y minus 2x. And then what? Now I'm going to add the 3y because I need the y to be on the other side. So add the 3y. So now I have 3y is greater than negative 2x. Divide everything by what? Say it again. Divide everything by 3. So this is the equation y is greater than negative 2/3 x. What is my slope and what is my y-intercept? The y-intercept is going to be 0. Yeah. This is what, do you guys remember doing direct variation? This is a direct variation equation. My slope is negative 2/3, meaning that I'm going to go down and then to the right. So I'm going to begin at 0, 0, and I'm going to go down 2 and to the right 1, 2, 3. Down 2 and to the right 1, 2, 3. Is this going to be a dashed line or a solid line? Why? Good job. It's just greater than. Awesome. So I'm going to dash this line. I cannot choose the test point 0, 0. Why? Because it's on the line. It's not going to help me, right? Does that make sense? It's not going to help. So the next best point to choose, if the point 0, 0 doesn't work, try the point 1, 1. So we're going to plug that test point into our inequality. So we're going to let x equal 1 and y equal 1. So that gives me y is greater than negative 2/3 times 1, which means that 1 is greater than negative 2/3. Is that true? Yes, it is true. So I'm going to shade everywhere on that side of the line where the test point lives. Meaning, this is what this means. This means that I could use this ordered pair and the inequality would be true. And I could use this point and this point and this point and this point. I could use any ordered pair on the shaded side of the line. And I could plug it into the inequality and it would provide me with a true statement. Okay, let's do it again. What kind of a line is this? It's going to be a solid line, yes. What else is it going to be? It's going to be vertical. Who said that? Good job. So I'm going to go to where negative 4 is on the x-axis. And I'm just going to put a solid vertical line. So we really know something about the symbol for that. What did it say? We said that the symbol, if it's less than or equal to, we shade which direction? Look at your notes from above. What direction do we shade in? To the left. This is saying any number that is less than or equal to negative 4 will make this true. Any number that is less than or equal to negative 4 will make this true. What kind of a line is y is less than 0? It's going to be horizontal, solid, or dashed. Horizontal, dashed. So I'm going to go to where y equals 0, which is right here, and I need to just put a dashed line. So less than tells me I shade either to the left or to the left or below. So make sure your line is dashed and then shade below it, meaning any number less than 0 lives in this area. Any number that is less than 0 lives in this space. Any y value less than 0.
How many things do we have? So,
Okay. So we're now going to write the inequality. And I don't know if you guys can you see like the gray little shaded space? This is your shaded region. So maybe darken that side in on your graph. Do you guys see that on number 6? This is like the shaded region. And on number 7, this is the shaded region. So just fill it in for me, okay? All right. So let's look at number 6. I need someone to volunteer to give me the slope and the y-intercept. Kane. It is -1. +1. Okay. So the slope is -1 and the y-intercept is +1. Kate, can you write an equation, not an inequality, write an equation for that in y equals mx plus b. Let's start with an equation.
like the y. Oh, okay. Y equals -1x plus 4.
Perfect. So if this were an equation, it would be y equals -1x plus 1. But it's an inequality. So that means I just have to change the equal sign. Okay? So I know that I'm going to change the equal sign to either a less than or a greater than, because the line is, why do I know that I'm going to change it? The sign is going to be changed to either a greater than or a less than. How do I know that? Because it's dashed. Because it's a dashed line. If it were solid, it would have a bar underneath it. Okay. So what symbol makes me shade to the right and above the line? The greater than symbol. Y is greater than -1x plus 1. Okay. So Kane, you can't answer this one. So next one, number 7. Meaning you can't talk. You're done. Number 7. What is the slope and the y-intercept? Eli, look at number 7. I'll help you out. Look, here are your points. You have a point right here and a point right here. What's the slope and the y-intercept? Remember, your slope is how much you go up and how much you go over. Awesome. It is. Yeah. It's 2/4, which reduces to 1/2. Very good. So you go up 1, 2 over 1, 2, 3, 4. Do you see that? Okay. No, don't apologize. So Corbett, you're going to write the y equals equation. X. Perfect. Daniel, are we going to use what two symbols do we have to choose between? Awesome. Okay. So I know that if it's above the line, it's going to be If it's above the line, what symbol? It's going to be greater than. So my inequality is y is greater than or equal to 1/2 x plus 2. I want to check this because I just want to make sure that I'm understanding it. So I'm going to use the point 0, 0 right here and see if that makes it true. Should the point 0, 0 make the inequality true? Should this point right here work when I plug it into the inequality? Why not, Brody?
Because it's not on the side that's shaded.
Yeah, it's not in the shaded in region. So let's plug it in. So I'm going to let 0. I'm just going to replace the x and the y with a 0. So 0 is greater than or equal to 1/2 times 0 plus 2. 0 is greater than or equal to 2. That's not true, and it's in the not true side. Okay, does that make sense? Kate, does that make a little bit more sense? You understand what we're doing now?
Yes.
Kind of? What do you think, Tessa?
Yeah.
Okay. On the next two that we do, I'll find one that's not true and show you like how you can check. Okay. All right. We're almost done, guys and gals. So sometimes you're going to be asked if the ordered pair is a solution. This is no different than plugging in an ordered pair for an equation. It's the same concept. You just replace the x and the y with the ordered pair coordinates. So what are we letting y equal in this inequality? What am I replacing the y with? 1. 3 times 1 is less than 2 times, what am I replacing x with? 2 plus 5. Let's see. 3 times 1 is? 2 times 2 is 3 less than 9. Is that true? So yes, the ordered pair 2, 1 is a solution. Remember that a solution is just something that makes the equation or the inequality true. So that point works. Okay, let's do the next one. What am I replacing x with? I have 2 times what? X is now going to be a 0. Minus 7 times y is -2. And it has to be greater than or equal to 14. Okay, so what's 2 times 0? 0. And what is a negative times a negative? Positive 14. Greater than or equal to 14. Well, is 14 greater than or equal to 14? Yes. So yes, the ordered pair 0, -2 is a solution. Okay. I can, yes. I'm going to freeze it, and I want, if your last name starts with an A through K, that's not very, what's the middle of the alphabet? Like L or M? I don't know. M. Okay, M. A through M does number 3. M and N through Z does number 4. Huh? A through M does number 3. N through Z does number 4. Ready, go. Last names. Nope, just do it on your paper. Watch out for number 3, it's tricky.
Oh, you did miss. Okay, how'd you do? It's okay, it's fine.
Ma'am. Yep. Oh my goodness. What do you got for me, Gavin? Okay. Let y equal 11 and x is negative 3. Is 11 greater than 11? Not. Yeah, right there. So this is y. This is x. It would be, I write it out just so my brain can process it like this. I have to see it or anywhere else. Then I change it to.
I'm not sure what I'm working on.
Especially.
3 minus 10.
That's what I'm talking about. History. And it always has.
So add 3 and 8. Okay, so it's 11 and 3. Is it? Good job. Yes, go ahead and put it up there. What'd you put? I told him he could do it, I'm sorry. He had it first. Yes, that's your answer. Okay. Sorry. What'd you guys get for, who's got number 4? Who has answer number 4? You want to go put it up there for me, Abigail? Yes, no? No, you don't want to? Yes, you do. Ah.
I think it's going to drive up here and write it
Right. Good job. It's not greater than. Is 11 greater than 11? What is number 9? Does that make sense? All right, so number 3 is correct. You have to do the negative of -3, which is a positive, and 3 plus 8 is 11, but 11 is not greater than 11. So that is not a solution. Number 4. Miss Abigail is putting it up there for us. And number 4, -7 is less than or equal to -4. And Abigail is writing, yes, it is a solution. How did you guys do on those? Both correct? Okay, good job. Good job. I'm not moving. That's not true. The screen is frozen. Guys, stop it. Shh. Are we good? Can I erase these?
Not yet, but yeah, I'm not done.
Pardon me?
We all do it now.
No, not right now. Are we done? Okay. Here we go. Next one. Which one of these are a solution? And it says select all that apply, I think, right? So which ones of these work? Well, let's just graph them. Let's see, -3, -2 is down here. This is question number 5 at the bottom. 2, number 3 is right here. 3, -3 is right here. So which one is a solution? Isn't B in there as well? Yeah, sure it is. The ordered pair 2, 3 is right there. It's right here. So remember that any point in that shaded region can be a solution. So inequalities can have multiple solutions. It says write the linear inequality for this graph. Where do I cross the y-axis? At 1. What is my slope? I don't think so. I don't think so. It's -4/3. I'm serious. Yep. It is. So what's my inequality? Is it going to be greater than or less than? Good job. You guys are doing really well with this. Kate, can I keep going? She made a boo-boo. Okay, you're good? Okay. All right, so here's your homework. This is where you start. You have questions 1 through all the way. You're doing pages 4 and 5. Pages 4 and 5. 4 and 5. Yes, I didn't stutter, I don't believe.